Layout animations are some of the most important yet easy to use animations in Codename 1. They make the application flow feel reactive and responsive. At the core of layout animations is the concept of explicit reflow. In Codename 1, layouts determine the position of components. That means that if you add a new component, it will be positioned by the layout. However, there is a big caveat. If you add the component after the form was shown, it won't position itself unless you do something like rotate the device, which implicitly lays out the component. You need to ask for layout explicitly. You can invoke revalidate to force layout. This is valuable for cases where you can add multiple components. In those cases, the layout logic can happen only once and can be much simpler. Layout animation works by animating the validate effect. It takes the components from their previously invalid or incorrect positions and moves them into their real final position. Normally, when you add a component, you won't set a size or position to it, as those will be determined by the layout manager. But with layout animations, this can be useful, as you can position a component explicitly and then it will animate from that position. This allows you to create a flow in the UI so components settle into place. This serves to draw attention to changes in the UI in most cases. Animate unlayout is the exact opposite or evil twin of the animate layout method. Animate layout takes layout in an invalid state and returns it to normal layout with an animation. Animate unlayout takes layout in an invalid state, returns it to normal instantly, then animates it into the invalid state. So if we want to move a component out of the form with an animation, we can set its X position to the screen width. If we call animate layout, we will get an effect of the component sliding into the screen from right to left. If we invoke animate unlayout, we get the effect of the component sliding out of the screen. When we run animate layout, we do something that's effectively the equivalent of revalidate, so the UI is valid once we finished. With animate unlayout, the situation is the exact opposite. The UI becomes invalid when we are done, which means a typical animate unlayout will be followed by an animate layout or revalidate. The purpose of animate unlayout is strictly as a visual effect, unlike its animate layout counterpart. There are a few varieties and a bit of noise, but layout animations generally fall into these two categories I mentioned. And wait versions of the methods use invoke and block to help you serialize calls to layout and unlayout. This is useful when you want to create elaborate effect with one piece relying on the completion of the next piece. Fade versions of the layout methods can fade components in or out. For unlayout, components are faded out, and for layout, they are faded in. This allows components to materialize or dematerialize gracefully. The hierarchy-related animate methods, such as animate hierarchy, are very problematic. They recurse into a hierarchy and try to lay out all of the elements within. But this is tricky, as you can run into a lot of edge cases, such as a component that moves from outside the clipping bounds of its parent's container. In this video, I activated slow motion mode, which is very useful for debugging animations, but for some reason the unlayout effect wasn't slowed down. So you can only see the deletion briefly, and then the animate layout that follows is slow. Let's go over the code that creates this animation. The entire animation is done in 5 lines of code. Let's go over them one by one. First, we set the deleted dish container to the display width, which pushes it out of the visible range with set X call. We now perform animate unlayout and wait. We maintain full opacity, which corresponds to the second argument. This animates the removal of the dish from the screen by sliding it to the right. We next remove the component that we animated out. This is important as we are currently in an invalid state, but the component is still in the hierarchy. Now we can animate the other element into their new place. Since the dish was removed, there is more available space, and we can use it by shifting everything into the new position.